afternoon, everyone. Our team is going to investigate the coordination of traffic lights and the measures that should be taken in the times of emergency. In Hong Kong, most of the roads are jammed by heavy traffic. So just imagine what will happen if a fire breaks out and roads are blocked. Fire engines cannot rush to the place of an accident as soon as possible. So today we want to examine how traffic lights be coordinated and what measures should be taken.
Studying the duration of red lights and green lights is our first step in our investigations. But how can we find out those terms? Let's refer to the figure first. Here is the the road system showing that there are 4 one-way roads, and we may name the roads be Street 1, Street 2, Street 3, and Street 4. Let's consider Street 1 first. The duration time of red lights TR should be long enough for the car, last car, that is the car at this position, to move across the zebra crossings. So, therefore, studying the motion of the last car is needed for us to find out the term TR. Here's the velocity time graph of the last car. At time equal to 0, the red light is lit. It's known that there is some time taken for every car to take the response for the color changes. So sometimes it's taken for the last car to wait, and we may define that period of time be the waiting time. Hence, the driver may take time for react to the motion changes of the car before it, and we call the time action and reaction times. And then the last car may accelerate using the acceleration A, but we know that the car cannot accelerate to the infinity speed. So it will stop accelerating until it reaches its terminal velocity. As we know that driver wants to reach its destination as soon as quick as possible. So the terminal velocity should be the speed limit of the road. Therefore, the term TG should be greater or equal to the 3 components of the last car. That is the waiting time, the action and reaction time, and the traveling times. But we know that we should minimize the term TG so that the effects on the waiting of the pedestrians can be minimized. So we use the equal signs in here. And after our calculations, the following results can be obtained, where C is the length of the vehicle, TA is the action and reaction time of the driver, V is the velocity of the vehicles, and A is the acceleration of the vehicles. But then, how can we find out the duration time of green lights TG? We can using the similar ideas for finding these terms. Let's consider the figure, this figure again. The term TG should be long enough for all the pedestrians to walk across the roads. Therefore, we know that the pedestrians are scared along the 2 sides of the roads. So we may let the population of the 2 groups of people be P1 and P2. These 2 groups of people may take T1 and T2 to walk across the roads. Similar to the case for red lights, the TG should be minimized so that it will reduce the effects on the waiting time of the vehicles. And so the maximum time of T1 and T2 is taken. And after our calculations, we have this result is obtained. And where VH is the speed of the people, and the P1 and P2 are the populations of the 2 groups. And our teammate is going to talk about the coordinations between the traffic lights.
This table shows the coordination of the traffic lights on Street 1 and on Street 2. R represents the period of red light, and G represents the period of green light. Obviously, L1 should equal to L1 over L1 plus L2 times P, which is the period of the whole system cycle, and it should equal to TR, which is the time required for the last car to pass through the junction. This ensures no extra car other than the new coming cars will accumulate in the street 1. So even in the worst condition, no traffic jam will occur. Similarly, G1 equal to L2 over L1 times P. So let my teammates introduce how the system applied. Suppose a fire breaks out. There is a fire department, and fire engines will come out from the fire department. And in order to let the fire engines rush to the place of an accident as soon as possible, the traffic lights should be well coordinated, so we can set up a detector to control the traffic lights if necessary. When the fire engine comes out from the fire department, the traffic light in this zebra crossing will turn on green light so that the pedestrian can come across the zebra crossing and prevents the cars from move this side. And this zebra crossing, the traffic lights will turn on red so that this car can go through this side. And when the fire engines come across this detector, the detector will control the traffic lights to turn on red lights so that those cars can go, will leave. And the time and the speed of the fire engine should not be slower than that of cars. And the time for the fire engines chasing this car should be at least equal to this car reach the end of the street, so that the collision between those cars can be prevented. And the distance, and D stands for the distance between the detector and the end of the street. Then let's show a mini movie to simulate. This is the time for the fire engine to reach the end of the D stands for the distance. VF is the velocity of the fire engine. Then let's show a mini movie to simulate the operation of the system. When the fire engine comes out from the fire department, when it comes across this detector, T4 and T9 will change to green lights and red lights respectively, so that this car can prevent from come out from this side when the fire engine goes through this side. When the fire engines come across the second detector, T15 and T16 will change to red lights and green lights respectively, and so on. The fire engine can go to the place of an accident immediately. That's the end of our presentation. Thank you.